Good morning to all. In the previous session, we have discussed about the register organization. In the register organization, we have discussed about the first registers, which are general purpose registers. So, general purpose registers are four, which are AX, BX, CX, and DX. AX can be able to store or can be able to perform the IO operations such as multiplication, division, byte storing, string manipulations, all those things, decimal arithmetic, all the operations can be done in this AX and can be stored the data into the AX register. Similarly, BX register, it can able to store the address information, nothing but the starting address of the segment which we are using, data segment. Count CX counter register, which can able to useful for count the number of loops present in your program. DX also can be able to do the word multiplication, word division, indirect IO. Okay, so for word multiplication, they require 32-bit of data to be stored. So you can mix this AX and DX as a 32-bit register, and you can able to store the DX register. Okay, how you can able to store? You can able to store the lower order 16 bits of the output into the accumulator, and the higher order 16 bits are to be stored into the DX register. Okay, so these are the four general purpose registers which we have seen in the previous session. In today's session, we are going for the second register, which is pointer and index registers. Pointer and index registers. Basically, this pointer and index registers are used as memory pointers, nothing but pointing to certain memory address. These registers will be pointing to a particular addresses in the memory. Getting point, nothing but offset addresses we can call. Yes or no? As we have seen in the previous session, in order to know our class, we should able to know the offset address, which is nothing but the room number, 4th floor, 5th room. So 5th room is my offset address. So these registers are useful for storing that offset information, offset addresses information. Get your point here. Right. So these are used in various forms of memory addressing. We should know the memory addressing. So these registers are being used for memory addressing. So as we are able to see, we have basically two pointer registers and two index registers. Okay, two pointer registers are SP and BP. SP full form stack pointer, BP full form base pointer. Stack pointer, base pointer. So in the case of SP and BP, the default reference to form a physical address is the stack segment. Stack segment. You will see the stack segment, all those things in the memory segmentation in the next session. Alright. So we have 4 segment register: stack segment, core segment, data segment, extra segment. These are the 4 segments. So stack pointer and base pointer will defaultly refer to the stack segment, whereas the index registers, which are SI and DI, source index and data index, source index and destination index, generally default to the data segment. SI, DI data segment, and base also data segment, SPBP stack segment. Okay, IP code segment. Getting a point here? Okay. So first pointer register, which is SP. SP is full form is stack pointer. It is used to hold the address of stack top. So we have a stack segment in the memory. So what is the top address will be pointing with in the stack pointer. It is used to hold the address of stack top. So stack top means is uppermost filled memory location. Uppermost filled memory location in the stack segment. So whenever the data is stored in the stack memory, the contents of stack pointer are first decremented and then incremented after every stack read operations. Stack last in first out, as you all know. So it should first decrease then increase in order to read the data stored in the stack segment. Getting a point here? So it points to the topmost memory location in stack memory. Now second one, coming to the base pointer, it will be acting as the you can call this as memory pointer to stack segment register. It is primarily used to access data on the stack and can be used to access the data in other segments as well. Getting a point? Stack pointer, nothing but memory. Okay. Base pointer also points to access the data whatever present in the stack segment and can also be used to access the data present in other segments. So these two are the stack pointer and base pointer, which comes as pointer registers. And the next, index registers, source index and destination index. These two are the index registers. Source index registers, it tells where the source is, from where I need to take the data. Getting a point here? Source, it is giving. So it basically represents with your data segment. So in the data segment where my data is being stored, okay, which is the location, which is the memory location from where I need to take the data is all about your source index register. Microprocessor will take the effective address of the data from the source index and stores in destination index. Getting point here? Clear? It takes the data from this and stores in destination. Nothing but source index is giving the data, stores in the destination index. It is required from some string operations. So when string operations are being performed, the SI register points to memory location in the data segment, which is addressed by the data segment register. Thus, SI is associated with the data segment in string operations. Similarly, the second one, destination index, it is a destination register. Okay, so whatever the source index are being performed, the data is being stored into the DI register. So here DI register points in the extra segment when you are going for string operations. When you are going for basic operations, it goes for data segment. But when we are going for string operations, it is associated with the ES, extra segment. This is one type of memory segment. Okay, the SI and the DI register may also be used to access data stored in arrays. Getting clear? This is the second type of registers, which are pointer and index registers. So coming to the third, which is nothing but flag register. So what are the different flags we have? So basically we have some 16 flags. Basically in the flag register it is a 16 bit. So as you all know, it is a 16 bit means 1 bit for each flag. So 9 of the 16 flags are being active and remaining 7 are undefined. Right. So overall we can call as we have 9 flags. So 9 flag in the flag register can be effective while doing the operations, while doing some control operations, while doing some execution of the instruction, which may affect your flags. So what are the flags? So out of this 9, 6 flags indicates condition flag or conditions status flags, and 3 flags are control flags. So these 3 flags are controlling the register. 6 flags are depending upon the conditions, they will be checking the status. So what are the 3 flags which controls? First one is TF, nothing but trap flag, which is a control flag. So trap flag, direction flag and interrupt flag are control flags. Trap flag, interrupt flag, direction flag. These 3 are control flags. Remaining 9 are conditional flags or status checking flags. Okay, trap flag, nothing but if any trapping is going on, when you are going for some debugging process, this enables nothing but there is it enables the trapping through an on-chip debugging feature. Interrupt, if any interrupt occurs, this interrupt flag will enables. It means an interrupt has been occurred. So first we need to clear this interrupt, then we can go for the other part of execution. Direction, it shows the direction whether we need to go for increment or decrement mode for DI or SI registers during the string operations. It shows the direction. It tells the direction in which direction we need to flow, whether it is need to increment or decrement. Getting a point? Like for example, in some programs, it directly goes to the loop, again come back. So when we need to increment, when we need to decrement the instructions, that this direction flag will tell. So first flag in the carry, if any carry occurs, see in our addition and subtraction there will be carry as well as borrow. So in that cases, this carry flag will tells the status. Parity flag, there are how many number of ones and how many number of zeros in your input depending upon odd parity, even parity. This flag will give the parity bit, nothing but even parity or odd parity. Auxiliary carry flag, when we are going for some addition or borrow, half bit subtraction, half bit addition, if it is carrying for the other half bit, nothing but 8 bit, 4 bits. If the first lower 4 bit gives the carry to the 5th bit, nothing but it having auxiliary flag and it will be enabled. 0 flag, if the output is 0, it is with this 0. Nothing but its flag is set. Sign flag, it tells the sign whether it is negative number or a positive number or output. And the last overflow flag, nothing but when you are going for the addition or subtraction of the signed numbers, it shows an overflow indicating that it is exceeding the capacity of the machine. There are 6 flags, and the last register which we are going to discuss in the next class, which is memory registers. Okay.